Okay, picking up where we had left off in the last video, I was going to show you just an extra little note here of how to find an equation for a line that is drawn, and just as a reminder. So I'm going to go ahead and put this in red ink since how we're doing something else that's an aside. So we know this point lies on this line here. If we have two points that are fairly well known, which this looks like a point that's well known, and that one's well known, we can find the slope of this line as well. So the slope, remember, is the rise over the run. So the rise from this point here to this point here is 1, 2, 3, 4, 5, 6, 7, and oops, it looks like actually this point right here is the better approximation for a point. And when I ask you to do this for real, I actually put dots where I want you to look, because it is really hard to tell on these things. Where do they cross at that point, or is it just slightly off, or what's going on? So I always really highlight that. So let's just say we're going to deal with this point right here and this point here. So again, rise over run. Rise 1, 2, 3, 4, 5, 6, and then 7. So my slope, my rise looks like 7, but it's -7, right, because it's going down. And then from there over, we're going to go run 1, 2, 3, 4, 5, 6. So we have a +6 rise. So I have a slope and I have a point, and these together can come into my point slope form to find the equation of the line. Now remember, your book uses the slope-intercept form twice in order to get this thing to come out to be an equation of a line. But remember, that's really unnecessary, because the point-slope form is specifically designed so that we can get the equation of a line using the formula and two very simple algebraic steps. So I'm going to say y minus, and I'm going to use the y coordinate here, 2 is equal to my slope, -7/6, times x minus my x coordinate here. So that's a 2 again. And now I'm going to simplify this. So we have y minus 2 is equal to -7/6x, and then negative times a negative makes a positive, and 7/6 times 2, I'm not going to leave that just by multiplying it. I'm going to make sure I simplify it. You should always simplify when you multiply fractions, and these will cancel, and so I'm going to get 7/3. Now here's the little bit of trickery. I have to move this 2 over to this side, so I have to move 2 over here by adding 2. Well, that means that I'm going to have to add 2 to both sides, but in order to add it to this fraction, I really need 2 in terms of thirds. So I have 2 over 1, and I need to make sure it looks like thirds. So 1 times 3, and 3 times 2 gives me 6/3. So I'm adding 2 as its equivalent fraction, 6/3. That just makes my life easier. So we have y is equal to -7/6 x, and then plus 7 and 6 is 13, and those are thirds. And that's perfectly acceptable. That's all we need to have. And that's the equation of this line right here, provided it goes through that point and that point right there. All right, now moving on to problem number 15. In problem number 15, we have solving a system using elimination. So elimination, the first thing we want to do with those two equations is we want to get rid of the fractions. So I'm going to clear the top equation by multiplying by the LCD 12. So I'm going to have 12 times 2/3 x plus 12 times 3/4 y, and then equals, and even though it's a whole number, remember it still has to get multiplied by the LCD, times 12. Now the second equation, I'm going to clear it by multiplying by 2. So I have 2 times 1/2 x plus And even though there's no fraction, remember I still have to multiply. 2 times 9y equals, and then again, even though there's no fraction, multiply 1 by 2. Now, what I end up getting from here is I do cancel here, and that gives me 4. And 4 times 2 is 8x. And then plus, and then I cancel. 4 goes into 12 3 times. 3 times 3 times y is 9y equals, and then 2 times 12, which is 24. On our next one, we're going to cancel. So 1 times x, which is just x, and then 2 times 9, which is 18, y, and then 2 times 1, which is 2. Now from here, we can see what we need to do with elimination. So I think I'm going to eliminate the y's here. So if I eliminate the y's, what I'm going to do is I'm going to make these y's equal but opposite. Well, equal would be 18. Opposite, one of them's got to be a negative. So I think I'm going to go ahead and I'm going to multiply this by a 2. I'm going to multiply this by a negative 1. And remember, that's the entire equation. Now you could just as well have multiplied by a negative 2 here. It's totally up to you, but I want to try to also remind you that you can multiply one or both equations. So we have 16x minus 18y, plus 18y is equal to 2 times 24, which is 48. And then it's a negative x, a negative 18y, and a negative 2. And so this gives us, this gives us 15x is equal to 46. And that will give us x is equal to 46/15. Now that is kind of an unfriendly fraction, but it's certainly a possibility for solving. And the way that I would go about solving it is I go about putting it back into an original equation and solving for the other one. So I would go back to one of the equations. So I'm going to go to the second one, 1/2 times 46/15 plus 9y is equal to 1, and I'm going to solve that. So this looks like 46/30ths, right? So I'm going to subtract 46/30ths from both sides and then proceed to solve. Now in order to do 46/30ths, I am going to go ahead and put this in terms of 30ths, or go ahead and reduce first and then put it in terms of that. Just to save some time, because I'm going to have to reduce anyway, I'm just going to put this in terms of 30ths, and then I'm going to reduce afterwards. So I have 9y is equal to 46 minus 30, and it'll be negative, so that's going to be a negative 16/30ths. And then before I go ahead and reduce, I'm going to multiply by the reciprocal. And the reason that I'm going to do the multiplication by the reciprocal first is because I might get some canceling that goes along. So y is going to be equal to a negative, and there is no canceling besides just taking out the common factor here and here, which is a 2. And so now I have 8 in the numerator and 15 times 9 in the denominator, so 15 times 9. Now do remember as well that you will be able to use your calculator on the test, so you can certainly do multiplication on their division. Fractions, you're going to have to do fractions no matter what, so please make sure that you are aware of your fraction work. So 46/15 is my x value. So I would write that just like that, comma, and then my y value, negative 8/135. And that would be my final answer. Now what we want to do is we want to show you that you can do it in two different ways. So let's go ahead and this time eliminate not the y's, but let's eliminate the x's. So just so you see that both of these are the same. So let's go back to the cleared equations, 8 and 9 and 24. So 8x plus 9y equals 24, and x plus 18y is equal to 2. All right, so if this were the case and I said, oh, you know what, I think I want to clear the x's this time instead of the y's. Well, we can certainly do that, and we're going to multiply this equation by a -8 in order to clear those. And so that's going to give us an 8x from the top one plus a 9y equals a 24, right? That's this, copy the top equation right there. And then I multiply through. So I have a -8x, and then I have to multiply 8 times 18. And again, because you'll have the use of your calculator, you could just plug that right in your calculator, so don't worry about it too much. But here is the value, 144. So that's -144, and that's y, and then equals, and that's a -16. So now we have 0 here, and now we have a negative, and 144 minus 1, that's 135y, and then that's equal to, and the difference between 16 and 24 is 8, and therefore we see that y is equal to a -8 135ths. And you see that is the same answer that we got back here, right? -8 135ths. So you're not doing anything differently, you're just solving for the other variable. So now in this one, we could put that back into an original equation and solve for the x. So x plus -8 135ths times 18 is equal to 2. So in this one, we know 18 times 8 is 144 35ths, so this looks like x plus a -144 135ths, and that's equal to, and I'm just going to put this in terms of 135ths right now, and that's twice that, so that's 0. Carry the 1, which would be 7, and then 2 times that is 2, so 270. So 270 135ths, and the reason I did that is because I'm getting prepared here to add the opposite to both sides and bring it over here, add the opposite to both sides, and that way I get that x is equal to, and this would be 4, and that would be 11, and that would be 414 135ths. Now you notice that that's not quite what we got over here, because we have common factors, obviously, and so we would have to reduce this down, which makes it actually a little bit more difficult problem. And if you divide both this one and this one by 9, you will find that this is going to give you 46/15, which is what we got. So this is divided by, and I don't have room, but divided by 9/9, just like that. And that will give you the 46/15 that we got in the first problem, the same answer. And that wraps up this worksheet.